Hello, standard form. Standard form. Have you ever imagined how very large numbers can be written? Say you have 38000000000000. Very large numbers like this. Or you have very little number, say 0.000000004, like this. If you always write numbers like this, it will actually take our space. Instead, we adopt a standard form method that helps us to write very large numbers or very little numbers in a particular format. You turn it to a particular form. That form is thus known as standard form. Standard form. Present it in a way like this: a times 10 raised to power n, where a is between 1 and 9. Between 1 and 9. Now, what does this thing mean? This thing means a will be from 1 to, 1, 2, 3, 4, 5, 6, 7, 8, or 9. This is what it means. 1 to 9. That's what a can be. Anything outside this, above that, that cannot be a. Now, it is said here, write the following numbers in standard form. The first one is 600,000. Now, if you look at this, since there is no point inside, it means that the point is outside. The point being outside, you want to drive the point to the first non-zero number. The first non-zero number is 6. So this becomes, let's write it out, 600,000. The point is here, let's go 1, 2, 3, 4, 5. So it's now in front of the first non-zero number, and we went 5 times. 5 times to the left. So this becomes 6.0 times 10 to the power 5. We have now written that in standard form. Let's see example 2. We have this. So 534,000. So the point is outside because there's no point inside. So it will be 534,000. No, the point is outside. We want to drive it to the first non-zero number. Remember, it will be in this form. Okay, let's say a point something. Okay, just say a times 10 to the power n must be in this form, where a should not be lower than 1, and should not be greater than, or should not be up to 10. Okay, so this will give us, let's go, 1, 2, 3, 4, 5. Similar answer, 5.34 times 10 to the power 5. Okay, now we move to the last one. We have 7,000, 7 million, sorry. 7 million, meaning that the point is outside. So we say, let's write it out. 7 million here. 1, 2, 3, 4, 5, 6. So we have moved 6 to the left. So 7.0 times 10 to the power 6. This is standard form for large numbers. Let's also look at standard forms for smaller numbers, just as we've introduced at the beginning. Let's take a look at this. These are smaller numbers, 0.00032. So you know where the point is. The point is here, but we want to drive it to the first non-zero number. Let's rewrite it. This is 0.00032. Let's go. 1, 2, 3, 4. 4. So this will give us 3.2 because the point now comes here. Why does it stop here? Because this is the first non-zero number, and look at 3 is between 0 and 10. That's between 1 and 10. So that's where we stop, times 10 raised to power. How many times do we jump? 1, 2, 3, 4. Negative 4. This is the answer. That is the answer. That is the answer. Okay. Let's also see another one. Sorry. Just a minute. Okay. So what if we have something like this, 0.01002? So this is same thing as 0.01002. So this is where the point is. We want to drive it to the first non-zero number. Let's go. 1, 2. It stops here because after scaling through a non-zero number, it stops. So our answer now becomes 1.002 times 10 to the, how many times do we jump? 1, 2, twice. Negative 2. Negative 2. That is the answer. That is the answer. You stop after scaling through a non-zero number. Okay, now let's see the last one. So we have this long one here, very small number. So let's go from this the point. We'll go 1, 2, 3, 4, 5, 6, 7, 8. You stop. Why did we stop? 6 is a non-zero number. So this gives us 6.08 times 10 to the power negative. How many times do we jump? 1, 2, 3, 4, 5, 6, 7, 8. Negative 8. This is the answer. That is about standard form. So next we go into is how to reverse it back to normal forms. Now let's look at this. This is another question. We want to turn this to its ordinary form. Now, when you say 3.8 times 10 to the power 3, the 3 is positive, and from your number line, you take the point to the positive part, which is to the right. If it is negative 5 or a negative number, you take it to the left. So, let's see. This, we just write it out, 3.8. Power 3, positive 3. You're taking 3 times to the right, so it goes this way. 1, 2, 3. So the point ends here. All the gaps, you fill them up with a 0. So this becomes 3800, and that is the answer. 3,800. Let's see the second one. You have 9.003 times 10 to the power 7. So this will give us 9.003. Let's go 7 times. Remember, positive 7 to the right. Let's go. 1, 2, 3, 4, 5, 6, 7. Is where the point ends. So you fill other gaps here with zeros. So you have, with this you have, let's see, you have 90 million 30,000. Good. So let's write it out so to be clearer. I don't know if, okay, let's see this. This is the answer. That is the answer. Okay, the next one. Now, this is a small number. Remember why? Because we're going to the left. So you have this. Let me shift to this point. 1.01. So we're taking the point to the negative side, the left hand side, 5 times. Let's go. 1, 2, 3, 4, 5. It stops here. So all this, you fill them up. So this is point, but look at this. This is, but you don't write down with point. So you just put a 0 because there's nothing in the initial place. Or so you just say 0 point. This is 0. This is the point now. You start. 1, 2, 3, 4, and 101. So this is our answer. 0.0000101. So that's the answer for it. Now the last one gives us this. Remember, like we said, -4 to the left. You're going to the left hand side. Look at to the left hand side. So this is to the right hand side, and this is to the right hand side. So let's see. This will give us, let's write it, 4.12, 4 times 1, 2, 3, and 4. We put the points here, fill this with zeros. But you know we cannot start with a point. So you just make a little 0 there. You start with 0.000412. And this is the answer. Please, I want you to practice this. Watch the video if you do not understand over and over again so that you can have a grasp on the concept. Wow, this takes us to the algebra of standard forms. Now, when we say the algebra of standard form, we're simply talking about addition, subtraction, division, and multiplication of numbers in their standard form. Now, we're taking addition and subtraction first. I think this is a little more easy, I think. Okay, so the first thing you have to do is make sure that the powers of 10 are the same. So here, to turn it that way, we're going to say this is 3.8 times this 6. It's saying that's 10 to the power 2 times, okay, let me plus 4 plus 8.7 times 10 to the power 4. 6 is the same thing as 2 plus 4. So this means that you have 3.8 times 10 to the power 2 times 10 to the power 4 plus 8.7 times 10 to the power 4. Look at what I've done. Your law of indices. Your law of indices. Your law of indices. I think most times they teach standard form alongside indices. Alongside indices. Now, if you look at this, this is the same thing as 3.8 times 100 times 10 to the power 4 plus 8.7 times 10 to the power 4. This also gives us 3, because 2 times, it moves 2 times, 380 times 10 to the power 4 plus 8.7 times 10 to the power 4. Now they are of the same, 10 to the 10 are of the same power, sorry. The 10s are of the same power. So we can now play with them, with this number. So we have this, let's come to the other side of the board. We have the 10 is common, so you bring it out. So this is same thing as 10 to the power 4 in bracket, because that's the HCF. If you divide, remove it, divide them by 10 to the power 4, this is what you have. You remove, it will be taken 10 to the power 4, will be taken out. You have 380 plus 8.7. So this is 10 to the power 4, 388.7, which gives us 388.7 times 10 to the power 4. If you look at it, let's take the points inwards. You have 1, 2. So this is 3.887 times 10 to the power 2 times 10 to the power 4. We have 3.887 times 10 to the power 6. This is the answer. I mean, some persons will be like, wow, is it just standard form that is this? Is it something different? Is there something different with this? No, it's actually easy. It's actually easy. Follow, play it again and again, or where you another example. We can solve this example in same way. Can say the same thing as 6.5 times 10 to the power 2 times 10 to the power 5 minus 9.2 times 10 to the power 5. Note, why did we break it this way? Many laws of indices, one of the laws of indices. 2 plus 5 will be 10 raised to the power 7. 10 raised to the power 2 times 10 raised to the power 5 is the same as 10 raised to the power 5, 2 plus 5, which is 10 raised to the power 7. We only simplify this to give us this. Why? So that we have 10 raised to the power 5 here and 10 raised to the power 5 there. So this is same thing as 6.5 times 100 times 10 to the power 5 minus 9.2 times 10 to the power 5. So this gives us 650 times 10 to the power 5 minus 9.2 times 10 to the power 5. We can do this way. 650 minus 9.2 times 10 to the power 5. Give you time to actually look at it. Look at it. I don't want to be too fast. Wow, look at it. Okay, so we'll say 650 minus 9.2. We have 640.8. Okay, I think I will write it here. So you have 6. Okay, let me write it up here. Or let me come to the other part of my board. You have 640.8 times 10 to the power 5. We can still have this same as take it in 6.408 times 10 to the power 2 because 100 times 10 to the power 5. So we have 6.408 times 10 to the power 7. This is the answer. That is the answer. Okay, this is for addition and subtraction. Addition and subtraction. Okay, let's go over to the next part. Now let's see that of multiplication and division. First, we have this for multiplication. Or to multiply 4.4 times 10 to the power 3 times 2 times 10 to the power 5. Now for this, we'll take these two will go together while these two goes together. Let me use the arrow and this. So this will be 4.4 times 2 times 10 to the power 3 times 10 to the power 5. This same thing as 4.4 times 2 times 10 to the power 3 plus 5. So this gives us 4.4 times 2 is 8.8 times 10 to the power 8. This is the answer. That is the answer. Straightforward. Okay, now let's see. Also, let's take an example of division. Let's see, division. Now let's divide this. In dividing this, let's rewrite it so we understand. This is 2.4 times 10 to the power 8 divided by 6.0 times 10 to the power 3. Okay, we can move it to this point, to this place. 2.4 divided by 6.0 times 10 to the power 8 minus 3. Why? Standard, as in indices, sorry, indices, we've broken it down. So if you divide this 2.4 divided by 6.0, you have 0.4 times 10 to the power 8 minus 3 is 5. 8 minus 3 is 5. Now let's let one out. So this is same as 0.4 times 10 to the power 1 times 10 to the power 4. We just allowed one come out because 1 plus 4 is 5. 1 plus 4 is 5. So we have the answer to be 0.4 times 10. Remember, 10 to the power 1 is 10. So this is 4.0 times 10 to the power 4. That is the answer. That is the answer. Okay, for more explanation, the number, just call the number on your on the screen just after this video, and I'll come to your aid. Bye.